to talk about generics and play with it. If you have any questions, we'll talk about it, change some code, just have fun. So generics were introduced in Java 5. If you look at the Java 5 features, there were quite a number of features that came into as language features in Java. Some of them, for example, were autoboxing. We had autoboxing introduced in Java 5. We also had the for each statement that was introduced. And then, of course, we had a few other things, including generics. The generics were really a welcome at the time because the collections that we had in Java were not really type safe. Java, being a statically typed language, gave us static typing and compile time verification for quite a number of things. Unfortunately, the collections like vectors and array list did not provide us type safety at all. So this was something that we were anticipating would make our life better. Well, unfortunately, it did not. And that's why the title of the talk is Good, Bad, and Ugly. I can probably talk about the goodness for 5 minutes, and then the bad for 20 minutes, and the ugly part for the next 30 minutes. And so this was quite a disappointment in a lot of ways, unfortunately. And this is especially even more disappointing coming from the point of view that I have worked with and used the generics in .NET quite effectively, and they have done a much better job of generics in .NET than it is in Java. Now, of course, the question is, why is that the case? What really went wrong? And one of the things that really went wrong is a design decision that the Java language designers decided to take. And that is, they wanted to provide backward compatibility. They wanted every piece of code that was written pre-Java 1.5 to still work and execute without having to be changed. And sometimes our past holds us back in moving forward. And that's one of the biggest concerns is that because they wanted to provide the backward compatibility, the Java generics did not provide us all the benefits that it could have provided. So that's enough talk. Let's look at what these things do, and we'll play with it and then take it forward from there. So what I'm going to do is just spend a little time talking about what generics do, and then we'll go further from there. So I'm going to start with a slight little code here. So let's say we're going to start with a main method, and I'm going to have an array list. Let's say array list, and then I'm going to say list equals new array list. So this is basically called as, now it is called as the raw type. So basically a raw type is essentially a type which doesn't use any generics, and that's what it's using here. So I created an instance of array list over here. And then what I'm going to do, and I was trying to increase the font size, and for some reason, it doesn't want to increase the font size, so I'm having a little trouble with this tool here today. So I'm going to try the best I can by zooming in. So then I'm going to say list.add, and I'm going to add a 1, list.add, and I'm going to add hello, and so on. And as you can see, I'm able to add various type of objects into this collection. So fundamentally, the Java collections from the ground up did not care about type safety. So the real problem is not in putting stuff into the collection. The real problem is when you take it out. So when you're trying to get something out of this collection, you pretty much have to know what the type of the object is that you're going to pull out. So for example, if I were to say something like int value equals, and then I'm going to say list.get0, that is certainly a problem because it says, hey, it requires a type integer, but I found a type object. So what you would resort to is to start using a typecasting, and to get the value out of it, you would try to do that. But again, in this case, it complains that you cannot convert from an object to an integer. So then what you would end up doing is you would say, okay, I'm going to convert this to an integer value first of all. And if you think about the pre-Java 1.5 days, that piece of code on line number 12 will not also work because you cannot cast from an integer to an int. So what you would do is you would do the casting of the integer, and then you would call the int value method on the integer because you didn't have autoboxing. So it'll go a little bit further effort to do. So what are the problems with this code like this. The first problem with code like this is you had to spend a lot of time casting objects. That's one concern. The second concern, it's verbose, certainly, but the second concern is that your code had to deal with specific type all over, rather than letting the compiler take care of things for you. You had to put in the effort to do some of these things. So generics were going to solve these problems for us, so we don't have to do the casting of things. So let's go ahead and give it a try over here. So what I'm going to do instead of this is I'm going to say, I'm going to create not an array list like this, but I'm going to create an array list of integer, and then I'm going to specify that this is an array list of integer. So we specified that we have an array list. Just as a very quick note, by the way, not related to this talk, but in Java 7, you would write code like this. You don't have to say integer twice in Java 7. So in Java 7, the syntax for this would look like list integer, list equals, new array list, and then a diamond with no type in it, because it will figure out what the type is based on what's on the left side. But we're not in Java 7 at this point, so you still put this integer here. Now I'm going to say list.add, and I'm going to put a 1 over here to put the value. You could argue, hey, 1.0 is nothing but a 1 for all practical purposes, but as you can see, it tells you that you cannot add that. So that's where the type safety comes in. But unfortunately, the type safety of generics is extremely thin layer. That's like walking on ice, not a good thing to do, right? And so this is helpful at this point, but the real benefit comes in when you're trying to get things out of this list. So let's say we got an element value 2 and a value 3 I have put in. Maybe I want to total these values out. So I'm going to say total equals 0. Now I could say for integer value in the list that I have, and I'm going to simply say total plus equals value, and then of course I could simply print out total is, and I'm going to print out the total value in this particular case. So if I go ahead and execute this little code that we just wrote, the total is 6, as you can see in the bottom, it displays it. So that was convenient. So what did we do? We did not have any casting at all in this code, so we could celebrate saying, that's great, we didn't have to write a lot of code for it. We didn't have to sit there and say, the element I'm getting from this list is an integer and I have to cast it. So that is the good part. So if you came to this talk to hear the good about Java generics, you already did. You can leave now. But rest of it is going to be pretty bad and ugly from here on. Any questions or comments before we move on? Nope? You really are here for the bad stuff, right? Yeah, who wants the good stuff? Tell me the bad thing. Yeah, we'll do that. So what's going to happen here? That's so far so good. But like what I said is if I try to do list.add 1.0, I get a compilation error. It says you cannot do that because 1.0 is not an integer. And based on the type that you specified up there, I cannot permit you to send a 1.0 because that's a double value, and you cannot send a double where an integer is expected. So again, that's a good news. It's certainly a nice thing to have. But unfortunately, what happens though is, suppose that you have a library somewhere which has a method called play, which takes a list over here. And what this method play method is going to do is it's going to take, oops, wrong one. What it's going to do is it's going to take a list, basically in this case a generic raw type. So import, let's say java.util.list. And what I'm going to do here in this case, let's make this a void method, is I'm going to go ahead and add, in this case, a list.add another value 1. And I'm going to call this method play from here. So I'm going to simply say play, and I'm going to send the list over to him. Right? That's all I'm doing. So now that I've called the play method with the list, if I go ahead and execute this little code, since we added one more value, the value is 7, as you can see. Life is good. But then what happens? Suppose instead of sending a 1, I decide to send a 1.0. Notice the compiler does an error. Right? At the best, it gives you a warning. It doesn't give you an error. But this could be deep in another library and that you're calling. This may be a third-party code. It could be a code that somebody else in your organization wrote. You're simply sending your object to it. and they wanted to provide this for the sake of backward compatibility, and so you have done this. Now, notice that this code doesn't have a compilation error. It compiles with no error, but when you run this code, unfortunately, what you end up getting is the infamous, where is that? The infamous class cast exception, as you can see. So generics actually suffers with exactly what it tried to avoid in the first place, is to remove these kinds of problems. So you do actually end up getting a runtime class cast exception in generics, so it doesn't provide you the benefit that fully that it was intended to. Now, of course, the concern is, why does it do that? That's because they wanted to provide the backward compatibility, and as a result, they allow you to send objects of generic type to raw types. It's good to avoid that as much as possible, but you just don't have a control over how your code gets used when you write APIs and so on. So that is bad. We have to be a bit concerned with. But I lied to you. There are a few other good things that we can still talk about, so I'll talk about some of the good things also, and then we'll come back and look at a few things where it can get pretty tricky. So we looked at, so should we still use generics? Well, they give you a slight advantage, and the advantage is that you can avoid these casting. But before you say you have avoided casting, it is still important to understand that you really did not avoid casting. This is purely a syntax sugar, if you will. So let's spend a minute on this and look at the concepts here for just a second here. So let's go ahead and get rid of this play method. Let's just get to the code that we used over here. Did I write it? Let's see what I called this. It's exercise, that's what I called it. So here's my exercise, and here's my sample class. I'm going to use Java P minus C. Remember what Java P minus C is, right? Java P minus C. Java P is a tool that will take the bytecode and it will reverse engineer so you can look at what it really created. So this is for those of us who are inquisitive. We never write code and be happy with it. We got to dig deeper and see what it really did. So we're going to look at Java P minus C and take a look at what it actually generated under the hood. And the class that we wrote here, I think I called it sample. So if I simply say sample over here, and then we'll pipe it to more, you can take a look at what it actually created at the bytecode level. So it says that this was compiled from sample.java. That's what it says over here. It was compiled from sample.java. And then it goes on to tell us that this particular class has a constructor over here. And then there's the main method, as you can see down here. And if you look at the main method, what does the main method do? The main method is simply going through the loop over here. Right there's the list.add. It calls the add method. And then deep down here, you would notice, where's this? Let me lower the font here so I can actually see it, and then I'll bring it back up. So, so we have the invoke static on the, did you notice that? So notice line number 28. The line number 28 is doing auto-boxing. So line number 28 says, call the integer.value off. So that's what it is doing right there on line number 28. So it is casting it back to the integer object and then calling the int value in it. So you are not casting, but the compiler is doing the casting for you. So you didn't really get rid of the casting. You simply just slid it under the rug, and it is still there behind the scenes. And that's why you get the class cast exception when you have the wrong type. So that's essentially what's going on under the hood, and that's what we just saw here. Okay, all right. Let's move on. So we looked at the disadvantages of this particular way of doing things, but you could still use generics to a certain extent to get some advantage, and it does have a few interesting features. So we saw a collection, how to deal with this collection of values here, but let's try something else. Let's say we have a class called animal. So I've got a class called animal. I got a class called dog, which extends from animal. And what I want to do here is I'm going to write a function. Let's create a collection of these first of all. So array list animals, and I'm going to call it animals, equals new array list. And I'm going to call this as array list of animals. So that's easy. So we got a list of animals. And similarly, I'm going to create an array list one more time. And this time it's going to be an array list of dogs. So I'm going to call this dogs equals new array list of dogs. So there we go. So we got two collections on hand. And I'm going to write a method called copy. So what copy does is it takes animals and it's going to copy to animals 2. I'm going to create another list of animals. So here's my array list of animals 2. Let's just copy this over here. So here's my animals 2. And how would I write the copy method? So let's go ahead and write the copy method. The copy method says I'm going to take an array list of animals, and then I'm going to, well, let's call this from for now. So from, and I'm going to say copy it to 2. So how would I implement this method? I'm going to say 2 dot, and I'm going to probably clear out everything I have. And then I could say for element, in this case animal, an animal in from, and I'm going to simply put that into 2 dot add an animal. So pretty straightforward, pretty simple, right? Nothing complicated. Let's see if this works. So I'm going to say animals dot add new animal, and I'm going to call the copy. I'm going to output animals 2 dot size and find out that it already has one element that I copied over, right? So there you go, it worked. Now what I want to do though is I am going to get a collection of dogs, and I'm going to copy a collection of dogs into a collection of animals. What do you think of that idea? Right? I got a room full of dogs. I'm going to copy the dogs from the room full of dogs to a room full of animals. Is that a good or a bad thing to do? Is that a right thing to do or not? What do you think? Yes, it's okay? Because the last time we checked, dogs are animals, right? So we can treat dogs as animals. That's okay. All right? How about the reverse of it? I'm going to take animals from the animals room and copy it to the dog's room. What do you think? No, not really. Because not all animals are dogs. So you got to go in one direction but not in the other direction, right? So there's a bit of a concern on hand. But let's get to that a little bit later. So notice what I'm going to do. I am going to create over here, I'm going to say dogs dot add new dog. So we created a dog instance, put it in the dogs list. And what I'll do here is I will say copy from the animals over to dogs. I'm sorry, the other way around, right? From dogs to animals. Well, before we go further, what I'm going to do is I'm going to make this method itself a generic. So I said this is of type T. You know what? I should actually step back for a second. Let's go back to the animals for a second. I'm stepping ahead of myself. So here's a generic type T. I'm going to change this to a T and change this to a T. That becomes a type T. So that is a way for you to create a collection, a method that uses generic type. So notice how I made that method generic. It was copying animals to animals a few minutes ago. Well, animals, or even animals too. Notice the compiler doesn't like it. The compiler says, no, I won't let you do that. It's fearful, right? So why does it say that? It says, I don't know if this is the right thing to do or not. When you guys are intelligent human beings, you know that this copying is valid, but how do I know that? I cannot be just general enough when using generics to do it. So if you want to put this into a technical term, this is a good thing. This is called Liskov substitution principle. Liskov substitution principle says that inheritance must be used only when you want to permit substitutability. If something is not substitutable, you should not use inheritance. So if you want to look at it in a slightly different way, you have a base class, like animal, and you have a derived class, like dog. So dog inherits from animal, but a collection of dogs, or collection of derived, does not inherit from a collection of base, or collection of animal. In other words, the inheritance relationship between two classes do not transfer to inheritance relationship between the collection of those classes. So a collection of dogs do not derive from a collection of animals. That inheritance is not valid because you cannot, in a general way, treat the collection of derived as a collection of base. You say, why is that? Well, here's an example. Let's assume for a minute that the gentleman over here has a bag of fruits. And the bag of fruit says, you can give him a fruit, you can give him a banana, you can give him an orange, you can give him an apple, and he's going to put that into this collection of fruits. And that's what he does. He keeps putting this into a collection of fruits, and he's happy doing it, right? Now, you tell him, hey, you know what? You receive these fruits, and you keep putting into this collection of fruits every day. Life is good for you. Tomorrow, you're going to report to work with this other guy who's going to help you. Well, assume for a minute that we allow this substitution, that a collection of banana inherits from a collection of fruit. Now what happens? He shows up to work not knowing this. And he comes up with this basket that's given to him. What does he know? He thinks it's a basket of fruits. But nobody told him it's not a basket of fruit today, it's a basket of banana. And what is the characteristic of a basket of banana? It only will accept bananas. And if you try to put apples or oranges in it, it gets very angry. It throws an exception, right? So what does he do? He says, give me a fruit, I'm ready to toss in. He takes a banana, puts it into the basket. Will it accept it? Sure, because it's a basket of banana, it accepts it, right? Then he puts an orange into it, and it blows up. And he says, well, this is a basket with an attitude today, right? It doesn't work. So he looks surprised because there's a violation of contract that's happened in this particular case. And that's what LSP wants to avoid those cases. It says, hey, we don't want those kinds of surprises to happen, so we will not allow this inheritance to take place. You say, okay, that's all nice theory, Venkat, but we want this to happen because we know that dogs can be substituted wherever animals are used. In this particular case, this is perfectly okay. So what you want is that override button. How is that override button going to happen? So notice what we're going to do. We go back here and say, hey, I want to copy, and where this is a type T, that's the type of T, which is dog. But what is special about this type over here on the second one? The second one can be either a type T or what? Or a base of the type. So extends from T, right? So you could say that I want this to be a type T here, or I want this to be an extension from type T. So we are saying I want this to be from this type. Or you can say this is going to be some type T over here, and I want this to be a type which is a super type. In this case, extends, I think. Extends T, right? So basically we are saying this can be extending from it, not the super type, but extends. So this says, I've got on the right side a type T, which is like an animal, and this could be either an animal type or a type that inherits from animal. So now as soon as I put that, notice that if I remove that and I only put T here, he doesn't like this. He says you cannot send a dog and an animal to this list. But the minute I replace it with question extends T, notice it is not complaining anymore. So generics give you this ability to specialize on the types and say, hey, I want this contract where this one type is of type T, whereas the other one can be a type that is of that type or a type that extends from it. So don't read this as something that extends. It is either of that type or a type that extends from it that gives you the flexibility. You could write it this way, or you could say, this is of type T, and the other one is a question super of T, right? So you could go either way, depending on what you're trying to do. Any questions so far? Yes? Don't hesitate. No? Okay. So that's basically one of the nice things about this is you can specialize. But that's also a bad news. What is it? And the bad news is, suppose you had this copy method which was using the raw type. And one morning you come to work and you've been asked to convert this from a raw type to a generic type. So you simply started putting T all over, and you compile your code and it works, and you say you're done, and So a couple of weeks goes by, and somebody takes your code, and they try to send in a different format, and things don't work all of a sudden. And then your company gets a support call from the library you released, right? So the moral of the story is, when you're converting code from a raw type to a generic type, you have to write different combination of test cases around it. You have to say, here's a simple usage of it, that works. Here is a bit more complex usage of it, that should work and does it. And here's another complex usage of it that should not work, and I want to make sure that this gives you a compilation error. So converting from a raw type to a generic type requires quite an active amount of work, more than simply putting type T's and saying we are done. So it requires quite a bit of thinking, different possibilities and combination of things that you would use. So that's one of the negatives, is you got to spend some time thinking about it and designing your code accordingly. Otherwise, you're going to be in for a surprise later on. So that is something to think about. Then comes the next set of surprises. And the next set of surprises is, what if you were to take a generic type and you're going to put certain values into it? Let's give it an example here. So let's say we want to create a list, our own list. So I'm going to create a list. I'll call it my list. So let's go ahead and create a my list. So class my list. Let's get rid of this. So here's my class my list. And the class my list is going to be of type T. And I'm going to provide a method called add. So add says T, and we'll say object that is going to add to it. I don't need to implement it right now. And then I'm going to say public void, let's say T, get int index. And that's going to return an element. I'll just return a null for now. But one of the things I want to do here is, I want to keep track of the number of objects of this type. So private static int, let's call it count. And I'm going to write a constructor. So my constructor here says count plus equals 1. So we added a value of 1 every time you create an object of this type. And then I'm going to say public int get count, which is simply going to return the count to you. So right there we have this code, right? So here's what I'm going to do. My list of integer, so I created a list of integer, we'll call it list1 equals new my list of integer. So there we go. So we created one object of this. What I'm going to do now is I'm going to create one more object of exactly the same type. And notice I said my list2. Here, one more. But this time the list3 is going to be of type double. And this is going to be of type double. So here's what I'm going to do. I'm going to output list1 dot get count. And similarly, I'm going to output list2 and 3. So notice that I'm going to say 2 and 3. Let's understand what we're trying to do here. I created two objects of my list integer, and I created one object of my list double. All right? So if you ask me how many instances of my list integer there are, the answer would be 2. If you ask me how many instances of my list double there are, the answer will be 1. So in an ideal world, what is the output I want to see here? 2, 2, and 1, right? 2, 2, and 1 because list1 is of type my list integer, but there are 2 instances of it, so it should say 2. List2 is also an object of my list integer, so as a result it should say 2. And there's only one instance of my list double, which is list3, and that should say 1. Are you going to see it? Yes? No?
You have to output that right after you instantiate it. Now you would see a 3, 3, 3.
You could do that too. You could output it right after you instantiate it, sure. But that's only a prioritization, right? The effect is the same as you create that, right? You could certainly do that if you want to. But are you going to see 2, 2, 1?
Basically, at this point when you're printing, you have 3 instances of my list.
No, but that's not the point, right? The point is there's a my list integer, and my list double. So in an ideal world, we have 2 instances of one type and 1 instance of another type. If you were to take this exact code and run it in C#, you will get 2, 2, and 1. Because there is 2 instances of my list integer and 1 item of my list double. And in an ideal world, not in the Java world, we all know already the Java world is not ideal, right? So in an ideal world, this would have been 2, 2, and 1, right? And like I said, you take this code and run in C#, that's what you're going to see, 2, 2, and 1. I'm not here to say that C# is ideal, but a notch ideal more than Java is. So what are you going to see, though, when you run this? You're going to say 3, 3, and 3, which is a surprise, right? Why should it be a 3, 3, and a 3? When you run this, it says 3, 3, and a 3. What happened? Something went wrong. Let's give it a try in a slightly different way. You say, hey, wait a second. You made this a static variable. If it really is static, why is getCount an instance variable method? That doesn't make sense. This better be static also, right? After all, if it's going to return to you a static field, that's got to be a static method. Why should that be an instance method? That's a fair point. So now what happens? Then I go down to look at this code, and Java says, it's not a good idea to call static methods on objects, because static methods don't use an object. They run on a class. So I'm going to change that. So what am I going to change it to? I'm going to change it to myList integer, because that's what I want to know, right? On myList integer. I'm going to change this to a myList integer, and I'm going to change this to a myList double. But notice what happened now. The compiler says, okay, fine. I will plead guilty, and I will admit the truth to you. There is really no myList integer. I was just fooling you. That's what the compiler says, right? It says there's no such class, and the minute you write this class, that type information just disappears. And you don't, when you publish your documentation, you don't document saying the type disappears. Would you do that? Your marketing guys will never let you do that. You don't say, this sucks. That's not the way you market it. So they said, we use type erasure. Wow. That sounds so well. Translate that to English, we screwed up. That's what it means, right? But marketing says, this is type erasure. It's like, whoa, that sounds so much better. So they did type erasure. So what did they do? What they did is, the minute you write the class, they completely erase the type. So let's look at an example here. If I were to go back here, so how would I really call this? And the compiler says, you really cannot call this here. You got to remove this from here. So now notice the compiler is so happy. It's like, finally, yes, I'll let you do that. So the real class is myList, not a myList integer or myList double. It is simply myList at the end of the day. So if you go back over here to write this here, and I'm going to put a type over here, let's say private T something, right? I created an instance of that here as a variable. Let's go ahead and compile this code. It's very clear at the code level what it's doing. But now if I go back and look at what we have, Java P minus C, myList, and look at what we have, notice the surprise. And the surprise is that get is returning not a type T, but get is returning a type object. Notice that add is not taking a type T. Add is taking a type object. Like I said, if you were in C#, for example, and try to do the same thing, and you use something like a .NET reflector, and take a look at the IL, the intermediate language code, you really will see T, because they preserve the parametric type for you, whereas here they've erased the type information, and so as a result, you lost that. So the bottom line is, the generics are a very thin layer at the compiler level. And they do keep a little bit of meta information in the bytecode, but it's very thin surface, and then once you get past it, it doesn't sustain after that. So that is something you got to be careful with, that type erasure can become a pain in the neck to deal with, and so generics do not deliver fully what they are intended to provide. Because of type erasure, their effectiveness is quite lost. and as a result. So this is not a failure of generics. It is a failure of certain design principles where they wanted to provide this feature and yet provide backward compatibility. But to be fair, it is an extremely difficult problem to solve because on one hand you want to make sure that old code continues to run fine on newer versions of your virtual machine. At the same time, you want to introduce new features, and so this is a design decision that organizations have to make. Do I promote this better capability and compromise and lose a bit of backward compatibility? Or do I preserve backward compatibility and jeopardize some of the features that I introduce? That's a hard decision to make. And at some point, we have to make the decision, and some people make better decisions than others. And in this case, the generics kind of had the suffering as a result of this, that we don't have the capability and we have to suffer through it. Will this ever get fixed? I really doubt this can ever get fixed. That's because it's rooted in the language. This is something hard because you have a bigger problem now because the code that's been written since then has to be backward compatible too, right? So now you got to carry that forward. So this is, we call that karma, right? So this is a karma that's been built up, and you got to deal with karma. There's not a whole lot you can do about it. So what's the moral of the story for us? The moral of the story for us is do not put static variables within generic types, because the static variables are shared across all instances and not based on the parametric type. That is something we got to be a bit careful with. The other thing also is there are certain restrictions, like you cannot create an array of generic types because that loses type information also. So a lot of times when you write code with it, you'll get a compilation error with these restrictions, and then you can know from those and you can handle it. So to summarize, generics were intended to provide a greater amount of type safety, but unfortunately they ended up not delivering on the promise that it started out with. And the reason is not because generics are bad, it is because of the backward compatibility desires in the Java community. This is something important for us to understand. Why? Because what we normally tend to do is we learn that something is good or something is bad in one language, but we don't know why it is good or why it is bad, and then we fear those things or end up foolishly liking it in other languages for wrong reasons. But knowing why something works and how it works or why it doesn't work helps us to make a prudent decision in evaluating other languages and improvements. So it's good for us to understand that. Any questions or comments before we wrap this up? Yes, please. Sorry, go ahead. They did not, because what they decided was, they said, let old code continue to work. And new code will use newer types with generic. They didn't retrofit the collections with generic. They created a parallel structure and said, let the old code use old system and the new code use newer ones and new namespace packages they created. And they said, you want this? Use new code. You want the old one, use the old code. And yes, there is a period of time when you cannot just interchange them, but for a greater good, we're going to move in this direction. I mean, this is purely a design decision, right? And that's the decision they made. And that's got consequences. But the net sum is better option in that regard. So that's where I would argue, again, without getting into a language bias, I would argue that C# is marginally a better language than Java, and it's over the time shown that. C# has a really nice features, including lambda expressions and link and so on, that you can use more effectively from C#. So certainly they have kept up with a few nice things. And you could argue, should Java really do it? But at this point, I would say Java as a language has really shown its age. And in its time, so if you really think about this, the Java, I'm going on a tangent to answer your question, but if you really look at this, the Java platform has only become more powerful. The Java API has only become more ubiquitous. But in the meantime, the Java language has become the weakest link. And so rather than using this weakest link to navigate through this beautiful powerful platform with this API, we could simply say, hey, let's take the benefit of this powerful platform, let's make use of this ubiquitous API, but we can use better languages that are much more effective in getting the work done and more productive. So at some point, we should use Java as a base compatibility language and not as a programming language. That would be the day to expect. I hope that happens, but that's going to only happen when you're all ready to move forward with it. And so the language, when Java was introduced, I'm sure you have read about this, right? They said Java is a simple language. That was a misprint. That was a misprint. What they really meant saying was Java is simpler than C++, right? And yeah, I agree with that. But we don't want to live with that baggage forever. We want a simple language, not a simple than C++. Other questions or comments, please?
You mentioned, like, as you mentioned, generics are implemented in Java via type erasure. But is that such a big problem for any developer? For example, okay, there are some cases where, as you demonstrated, which are like problematic. But I can write good code in Java and continue doing my development, despite knowing, okay, it is type erasure, but it is not affecting me very much.
This is what I love about Java programmers. They have hope. They have relentless hope. And I want you to continue to have it. Next question. What is the issue with arrays and generics? Okay, so step back for a second. Forget about generics for a minute. Right? Forget about generics for a minute. There are two issues. Arrays are evil, don't use them. Why are arrays evil? Why shouldn't we use them? The reason is, if you look at, this is another language decision, right? Nothing to do with generics, by the way, just for a minute, right? When you take an array, what they did was, you have an array of int, array of double, array of char, array of what have you. You want to copy one array to another. How do you effectively copy an array to another type? And they said, hey, here's an idea. Because we are the language designers, and we are also the API designers, we could do things a little bit different than other people who don't have that capability. So what they did was they said, if you send an array to a function, we will allow you to treat an array of int as an array of object. We will allow you to treat an array of double as an array of object. So they violated Liskov substitution principle fundamentally when it comes to arrays. So as a result, arrays are fundamentally not type safe. So that is one of the reasons we should not use arrays as much as we can. We should try to use the array list and so on. So that is independent of generics. But when it comes to generics itself, if I were to go create a collection, an array of types, so something like, first of all, you cannot do some of these things. If I said something like equals to new t, let's not even get to the collection for a minute. Let's come back to that later. So I'm going to create a collection of new t. Notice it doesn't like that. And the reason it doesn't like that is because of type erasure, right? It says you cannot create an instance of t because we erased it already. So we don't know what t is. So we cannot create a value of dog or cat. We cannot do it. The same problem continues. If you were to use a collection of t, and you say, I want to create something like this, right? Now what happens? He is like, you want a collection of these values, but again, type erasure comes in. So those kinds of problems magnify. So there are two discrete problems here. One is the arrays itself are poor in terms of type safety, and then because of type erasure, arrays are not being handled. And there's more problems you will discover as you work with it. So arrays are not very kind to you when used with generics. That's where it's going to get complicated. Are we out of time or we have more time? 5 more minutes, cool. Any more questions, please? A little louder, please.
What is the impact on the performance of the program?
There is no impact at all except for the typecasting that still happens. So there's a minor performance problem, but it's not really a performance problem. It is more of an obfuscation problem. What happens is when you have an integer, array list of integer, when you pull something out of it without you realizing, there is an auto boxing that happens all the time. And then when you put stuff into it, there's an auto-boxing happening all the time, auto-boxing and auto-unboxing. You could argue both ways. That's not a performance concern, or you put it into a huge loop that could become a performance concern. I'm not going to throw a performance concern on it. It is just that be aware that there's an auto-boxing and auto-unboxing that's happening, and that's just it's hidden behind the scene, so you don't realize it. But I wouldn't say, I would say performance-wise, you're not going to see really huge concerns related to that. Yep.
One of the biggest concerns for the excess baggage that generics carries forward is primarily because you said backward compatibility.
Right.
I mean, the legacy has to be carried forward.
Yep.
Now, the thing is, when you look at Java, one of their primary marketing campaigns, or I'm assuming, is like that you just install once, you run it everywhere, and...
Wait. That's
no,
do you work for Oracle?
No, I
Then
don't
you
work.
say it differently. You install it once and debug everywhere. Okay, go on. All right.
So now, if like truly Java can actually encompass the goodness of generics if it went with Java 6 compiler. You know, it came up with its own version of compiler, as is the case with C hash, right?
Right.
Now the thing is, when someone makes a decision of that magnitude, that should we actually say that I have at a corporation level, now Java probably is targeting things like at a corporation level. They've already got the world around developing so much of code, which is based in Java, different versions, that they don't really want that, okay, they bring in another level of granularity saying that, okay, Java version compilers. So, I mean, how big or how bad is that decision? Can that be actually summed up? I mean, is it just?
So let me make sure I understood what you're saying right. And I could be interpreting you wrong, so correct me if I'm wrong. But what I heard you say, assuming I heard you right, is, you know, hey, is it possible that in a future version of Java, we could have a different version of generics which does behave properly? Is that what you're saying?
No, I didn't say that, because that's not possible because of the basic tenet of Java's development program, which says that, okay, we're going to make code you write in any of the previous versions is going to get compiled in our current version also.
Okay, so to help me out, I didn't really get what...
So the thing is, if can Java actually make, the people who are designing Java,
yes,
the community, can actually make that decision that's, okay, let's move out from this, you know, this grappling hook and say like, okay, going forward, we come up with another compiler, and none of your if you write code and try to run previous version codes, they're not going to run on this. That is a cost, that is a...
Okay, so you can use backward compatibility with compiler version 1, or one name of compiler, but if you don't care about the backward compatibility, but you really want type safety, here is another compiler.
Exactly.
I got good news for you. They already did that. When they finished it, they called it Scala. Seriously, Scala takes care of those problems quite a bit. And that's what you're doing, right? If you have a different compiler...
That brings us to the second question.
Yeah.
How many corporations, because assuming we are writing code to make money and corporations adopt it, how many people are using Scala out there?
I really
don't... I might be wrong.
I really don't like the question how many do it, because if the world has a lot of fools, I don't want to say I want to be one of them.
Of course.
Right?
But
so, I mean, I've said this before and I say it again. If you want to follow what the world follows, you're reading to the path of mediocrity. So the question is not how many, how could we succeed with it? An example is Twitter. Twitter said, hey, we really need to really control these whales that keep popping up. You know what I'm talking about, right? And they said, well, we're not getting good performance and concurrency because anytime people start twittering in a conference or where there's events, a whale keeps popping up. And they said, okay, what's the problem? The problem is scalability, and the problem is concurrency. Okay, is there a language that can give us scalability and concurrency? Yeah, there's one called Scala. So Twitter's backend is built with Scala. There's one example. And there are other companies I know of, I cannot mention the names here, that have enormous concern with concurrency in telecom and networking. And what they said is, you know what, we are our Java deployment, but the beauty is we don't have to ditch the platform. We like the platform. The Java platform is extremely powerful deployment platform. We don't want to ditch the APIs we already have and the libraries we have built. However, we can leverage existing libraries in the platform, but with a language like Scala, because it gives us the concurrency solution in this particular case. And so they have went on and used it. So if you're looking for the world to use it, that's not going to happen. But there are companies that are doing significant business that have adopted it and have significantly
So we're
benefited.
basically looking at companies also, thinking of let's just ditch the past and reinvent ourselves. Now that brings us to a different
Right.
level.
So in a lot of ways, what you really need to look at is not what your competition does, but how you could stay 10 steps ahead of them. And to do that, you cannot be doing what they are doing. You got to take a few steps that gives you the leverage, right? That's where the real key is. We are out of time. Thank you so much.